With PMEL, we selected a core of about 20 different ocean sensors, which we integrated into the Saildrone over the period of 1 year. This year, we're moving forward on the back of last year's success in the Bering Sea. We're going back again with the same 2 vehicles, with the same science payload, but including one key instrument, which is the science-grade fish finder.
Saildrone work is going to be done during the time that we're doing an acoustic trawl survey of walleye pollock in the Bering Sea. This is a large fishery, and we conduct semi-annual surveys to measure the number of fish present in the area, and that's used directly to set fishing quotas.
If it could detect the presence of these endangered whales, that it would get us information that is just brutally hard to get from ships and other traditional means.
Having autonomous systems surveilling the sea is what we think is the future.
All right, welcome to the Pacific Marine Environmental Laboratory, including all of you that joined us here physically today, as well as those of you that are joining us on YouTube. What you just saw was a sneak peek at an exciting new project that we're just starting in the waters off of Alaska this summer. And if this technology is successful, it can provide a new platform that scientists can use to remotely study the oceans and do research that was not possible before. This mission is a collaborative effort between NOAA Research's Pacific Marine Environmental Laboratory, NOAA Fisheries, Alaska Fisheries Science Center, the Saildrone Incorporated, Green Ridge Sciences, Kongsberg Maritime, the University of Washington Joint Institute for the Study of the Atmosphere and the Oceans, as well as the Marine Mammal Commission. Last week, we launched 2 Saildrones in an effort to study the eastern Bering Sea. And these are autonomous sailing craft that you just saw in the preview clip that we just showed at the start of this broadcast. These Saildrones are equipped with technologies that allow us to measure physical and chemical parameters as well as biological parameters that help us to better understand whales, seals, and fish in these remote areas of the Bering Sea that would otherwise be very costly and difficult to monitor from a research vessel. With these platforms, we're able to gather data that are to help us better understand warming temperatures, sea ice changes, and ocean acidification in these highly productive waters. Last summer, the Pacific Marine Environmental Lab teamed up with makers of Saildrone to conduct a 3-month survey that was very successful. We were just measuring the physical and chemical parameters at that time, but the Saildrones covered over 2,000 miles in that study and made over 40 million measurements as these platforms followed the sea ice retreat in the eastern Bering Sea. Last week, as you saw in the video, Richard Jenkins, the developer of Saildrone, launched 2 more Saildrones out of Dutch Harbor, Alaska. And for this year's mission, which is the first time that we're linking the physical and chemical measurements together with these remote biological observations. So to talk about that, I'd like to introduce Doug DeMaster. He's the director of the Alaska Fisheries Science Center and the team of scientists that are planning to conduct several important research projects as part of this Saildrone mission. Doug?
Thank you, Chris, and thank you everyone for coming today, and thanks for everybody on YouTube for watching this. The Alaska Fisheries Science Center is really thrilled to be partnering with PMEL and others in this project. Research in Alaska, as you know, is expensive, it's difficult to get to, it's dangerous, and it's costly. We're very hopeful that this partnership will lead to kind of a new way to study the environment in the Bering Sea. One of the things that the information we'll be using this year will be helpful in terms of managing the largest fishery in the U.S., the pollock fishery. And in addition, we're also hoping to collect information on protected species. And of course, it's this information that we use for trying to promote the recovery of protected species that occur in Alaska. The outcome of the research, we hope, will provide for ensuring a stable production of seafood for the U.S. We also hope that this information will allow us to protect jobs in terms of commercial fisheries and recreational fishing in Alaska. And we hope that it will help us preserve a way of life that has endured for thousands of years for many Alaska Native communities. So the 2016 Saildrone mission builds on last year's mission, and the scientists will again be collecting oceanographic data as they did last year. But this year in 2016, we're also going to be collecting biological information, and so that's something that's new. We have 4 projects that will be conducted using the Saildrone as a platform this summer, and we are combining oceanographic information, biological studies to generate a more complete picture of the relationship between marine mammals, fisheries, and the environment in the Bering Sea. So we have representatives from the 4 scientific research teams with us here today. I'm going to invite each one to share a little more about their specific research projects, and after each one has had a chance to provide a quick overview, then we'll open up for questions and answers. So first I'd like to invite Phyllis Stebbino from the Pacific Marine Environmental Lab to speak about her planned oceanographic work. Phyllis's work is helping to build a baseline of environmental conditions that will help us determine how future changes due to climate change and other factors are affecting the Bering Sea in Alaska. Phyllis?
Is a large semi-enclosed sea. To give an idea of how large it is, the eastern half is a shallow shelf, and which is much larger than the state of California, and the southern boundary is longer than the east coast of the U.S. This vast area supports one of the most productive marine ecosystems in the world, with vast numbers of marine birds, marine mammals, and fish. In fact, almost half of the U.S. catch of fish and shellfish come out of the Bering Sea, and this supports a multi-billion-dollar fishery industry. In addition to commercial fishery, this marine ecosystem also provides about 3/4 of the subsistence harvest that the indigenous communities that are scattered along the coastline use each year. The Bering Sea is a high latitude sea. That means that in December, ice begins to form in the north. It's advected southward, usually covering much of the Bering Sea. This means that in the north, it's ice covered for about 6 to 7 months a year, and in the south from 1 to 3 months. This makes it a very difficult place to study year-round. So the Bering Sea, as I excuse me. Like most high latitude seas, the Bering Sea is very sensitive to climate change. So how the Bering Sea ecosystem would respond to a reduction in the ice and warmer conditions is an important question that we're now investigating. We have noticed marked changes in the Bering Sea in recent years. For instance, from 2001 to 2005, there was virtually no ice on the southern shelf, and there were very warm conditions. Connected with this was a very low recruitment of pollock for those years. The mechanisms, well, the low recruitment in turn caused a lessening or lowering of this quota for fisheries, for the fishing catch, by almost half. The mechanisms were not clear, are still unclear on what's caused it, but we have another opportunity. After 8 years of cold conditions, in 2014, the Bering Sea shifted again to warm, and that has continued in 15 and 16. So this year, we have an opportunity to explore the mechanisms that are they're affecting the ecosystem, such as the lowering of the stock. To do that, we need to have a large number of measurements. But as I said before, this Bering Sea's size, the harsh conditions, and its remoteness makes collection of data difficult. Data is typically collected using research vessels during the ice-free period, and with moored instruments throughout the rest of the year. In recent years, there has been a rapid advances in the development of new high-tech platforms and instruments to sample the ocean and atmosphere. By augmenting the traditional sampling via ships and moorings with this new technology, such as the sail drone, which is what we're going to discuss today, we can expand the spatial and temporal scales of what we're measuring, which is critical to answering the questions of why is the ecosystem responding to these multiple years of warmth. And we can also monitor these changes as they occur. Thank you.
Thanks, Phyllis. Now I'd like to introduce Jessica Krantz from the Alaska Fishery Science Center. Jessica is going to talk about eastern North Pacific right whales. This is an extremely endangered population, and this novel research we're hoping will lead us to helping locate some of the very few remaining animals of this species in the eastern Bering Sea. Jessica?
Sorry, take two. So our project involves passive acoustic monitoring of marine mammals with a focus on the North Pacific right whale. There are only an estimated 30 individuals left, and very little information is known about their full distribution range or migration patterns in the Bering Sea. We know that they are consistently detected in one portion of the southeastern Bering Sea each summer, but conducting the full-scale marine mammal surveys needed to monitor their entire historical distribution range is prohibitively expensive. But by integrating with the sail drone, we can cover a large spatial area, especially to the west of the 70-meter isobath, that we have not been able to cover in over a decade. So this will hopefully help fill in some of the current gaps in knowledge regarding the spatial distribution of right whales in the Bering Sea. To that end, with funding from the Marine Mammal Commission, we have integrated a passive acoustic recorder, the AcuSound, designed by Bill Burgess of Greenridge Sciences, into the keel of each sail drone. This instrument will record marine mammal sounds continuously throughout the entire mission. We will identify right whales by two of their call types, the gunshot call and the up call. If we are successful, the data obtained from this project will help us better understand the distribution of this critically endangered species in the Bering Sea and will help guide conservation and research efforts in the future. Thanks.
Thanks, Jessica. Next, Alex DeRobertis from the Alaska Fishery Science Center is going to talk about pollock. As many of you know, pollock is the largest fishery in the U.S. It's a multi-billion-dollar fishery. We're hoping that this partnership will allow us to look at new technology that may allow us to expand our surveys both in spatially and temporally, and to get a better idea of how climate change might affect this stock over the next few decades. Alex?
Thank you. We're making an acoustic measurement of the abundance and distribution of walleye pollock, which is a key species of fish in the Bering Sea ecosystem. These fish are really abundant, and they're an important source of food for fish, seabirds, and marine mammals. They also, as been mentioned earlier, support the largest commercial fishery in the United States. To help manage this fishery, NOAA has conducted acoustic trawl surveys of pollock since the late 1970s using research vessels and acoustic technology. We're now attempting to make similar measurements with unmanned vehicles. There's a backstory to this work. NOAA Fisheries have been working with Simrad Fisheries, which is a division of Kongsberg Maritime, to help develop miniaturized low-power scientific echo sounders, in which we were trying to measure the abundance of pollock from moorings mounted on the seafloor. These devices, like all echo sounders, work by emitting sound pulses into the water and then measuring the faint echoes that return from objects such as fish and plankton in the water. The way they work essentially is the more fish in the water, the stronger the echo. We deployed prototype instruments for the first time last spring on the seafloor. Just about at the same time, Saildrone and the Pacific Marine Environmental Laboratory had conducted a successful Saildrone mission in the Bering Sea, which you'd heard about earlier. It was clear to us early on that these two technologies strongly complement each other. For example, the Saildrone is mobile, and it generates enough excess solar power to allow us to operate this echosounder 24 hours a day. And the echosounder allows us to image the entire water column using the Saildrone, so it really expands our field of view. We've all worked together over the last year or so to integrate and test these two technologies, and it's been very productive and enjoyable. The bottom line here is that ship time is costly, and we're trying to explore how echosounder-equipped Saildrones might be used to expand our ability to observe fish populations in both time and space. The work really has two main goals. The first is really to characterize the suitability of echosounders on Saildrones. The way we're going to do this is make measurements over a wide range of weather conditions, because environmental conditions can affect the measurements themselves. We'll also compare observations from Saildrone to those from the NOAA ship Oscar Dyson, which will be conducting a Pollock acoustic survey. This vessel was purpose-built to make high-quality acoustic measurements. The second goal is to conduct a study of prey availability to satellite-tracked northern fur seals, and you'll be hearing about this from the next speaker. In short, what we're trying to understand here are the advantages and limitations of unmanned vehicles as platforms for acoustic measurement of the abundance of fish and plankton. We're optimistic that there's a lot to be learned from combining these two complementary technologies to make observations at times and places that otherwise wouldn't be possible. Thanks.
Thanks, Alex. And finally, I'd like to introduce Alaska Fisheries Science Center marine mammal biologist, Carrie Kuhn. She's going to be talking about the relationship between Alaska pollock and northern fur seals. Northern fur seals are dependent on pollock as a prey item. They're also a depleted species. It's a species that's been in decline for over 30 years, a decline that we don't really understand, and we're hoping that this work will help us better manage this stock to recover.
As a part of the Saildrone mission, our research group will integrate studies of northern fur seal behavior with the fish abundance data collected by the echosounder, which Alex just described. This will allow us to gain a better understanding of the relationships between northern fur seals and their primary prey, walleye pollock. During the summer months, the largest proportion of the world's population of northern fur seals can be found on the Pribilof Islands in the southeastern Bering Sea. This population has been experiencing an unexplained decline since the mid-1970s, and this is where we're going to conduct the research. Between July and October, fur seals from the Pribilof Islands feed on walleye pollock and other schooling fish, and often travel over 150 miles from the colony to find food. Due to this large foraging range and lengthy breeding season, spatially and temporally linking fur seal behavior with prey availability has been a long-standing obstacle. This summer, we'll track the foraging behavior of 30 northern fur seals using satellite-linked behavior recorders that will allow us to measure their dive and movement patterns from our office here in Seattle. By concurrently measuring fur seal behavior and prey availability via the Saildrones, we'll finally be able to spatially and temporally link these data sets and fill a critical information gap. This project is a significant step forward in our understanding of how the distribution and abundance of prey influence fur seal behavior, feeding success, and population trends. And these data, integrated into our larger northern fur seal program, will be used to make informed management and conservation decisions, which are critical as this population continues to decline.
Thanks, Carrie. So you've heard about the four biological research, or the four research projects we have going on this summer. The oceanography work, got work on eastern North Pacific right whales. We've got work on pollock and work on the interaction between northern fur seals and pollock distribution. At this point, we hope you enjoyed and appreciated the short snippets that we didn't have time for a lot of detail. At this point, we want to open it up for questions and answers, either here in the room or through the YouTube chat line. So should we open up to the room first? Yeah. Okay, do we have any questions for any of our researchers who you heard from, or questions about the overall mission? Please don't be shy. So the question is the path of the drone known, or can it be changed dynamically? It's been preset, but it can be changed dynamically. Through a web connection, you can direct the sail drone to change a course or heading. So for example, if we find an interesting spot where the fur seals are, we can direct the drone over that area. Is Richard on the line?
No, he's
Noah. Yeah. Noah's on the line. Noah with an H, not the big Noah, but our Noah.
Can you bring
So I'm an engineer on this project.
grab the mic?
Microphone behind you here. And restate the question.
All right, so the question was about how, if we can actually change the tracks of the sail drone and kind of send it to different places in real time, and how that happens, and what the web interface is for that. So Richard at Sail Drone Incorporated is the company that makes the sail drone. So as part of the sail drone operating system, they have a web-based interface. So basically, I can sit in a coffee shop or anywhere with a web connection on my iPhone, on a laptop, on an iPad, anywhere like that, and you can in real time basically send the sail drone to different positions. And the way you do that is you change, it sets to a series of waypoints. You can say, oh, okay, I want to send you over to these waypoints. And the sail drone then makes the corrections on board on how it actually sails to those waypoints. So, we're not basically saying, tack, we basically say, just go to this position in the ocean, and the sail drone figures out how to do that in real time. Yes, it uses GPS and it has satellite telemetry. Basically, we're talking to it pretty much every 3 minutes. We're talking back and forth.
Thank you. Other questions? Yes.
Is there anything
But wait for the mic. Sorry, I should have.
was there anything in last year's data that stood out or had any particular importance? And do you expect anything to stand out this year in the findings?
For Phyllis or Chris?
Could you repeat the question? It's really hard to hear.
Oh, yes. Was there anything in last year's data that stood out or was a surprise or of anything of particular significance? And do you expect anything this year to stand out in that matter?
Phyllis, let me repeat the question. It's easier for me with a mic up here. It's not your fault. It's the room. So the question had to do with 2015 when you did the pilot study on oceanography. Was there anything that surprised you? Was there anything that stood out in the 2015 oceanography work that we might anticipate either seeing or not seeing in 2016?
As a physical oceanographer, some of the things that really interested me, first of all, 2015 in the Bering Sea was extremely warm. It's the warmest year that we've seen. And the frontal structure around some of the islands was very sharp, which has certain implications for what happens around the islands. I'm hoping with this year, when we go out and look at the fur seals and that type of thing, we'll be able to see that structure or see what kind of structure is around the eddies and such that are along the coast. Last year was more limited in what we could measure. We just did mainly physical and some chemical measurements. This year I'm hoping to be able to integrate what we see in the physics and the chemistry with the broader biological. Why do the fur seals go to certain places to feed? Why are there hopefully we'll see higher concentrations of pollock in certain places? Is that associated in any way with the surface temperature and salinity and that type of thing?
Thanks, Phyllis. Okay. Questions? Yes.
Hi, I had a question about the acoustic readings that you're planning to do. I imagine the sail drone itself generates a certain amount of noise, other, splash, and maybe the motors or whatever it uses. I'm not sure. I was wondering if you could sort of comment on how you separate out, the sort of functioning noise from the readings that you're trying to take.
Sure. Thank you. I'll repeat the question, and probably Alex and Jessica, if you could help us out with this, that'd be great. The question has to do with the Saildrone itself probably produces noise, and when you have the Saildrone producing noise and you're collecting either a reflected signal for the active acoustics, or when you're recording underwater vocalizations from whales through passive acoustics, how do you tease out or distinguish the sounds you're interested in from the mechanical sounds or electrical sounds that are made by the Saildrone? So Alex, why don't you start, and then Jessica.
Sure. From the point of view of the active acoustics that we're doing, it's really high frequency, 70 kilohertz. So essentially the Saildrone itself, the platform, doesn't produce any sound in that frequency band. What you really worry about there is electrical noise, but that's really not really an issue on this platform as well. We don't have a lot of crosstalk, so things look pretty good. The main limitation that we have is that the transducer is about 2 meters deep, so it's not very deep. So when you get lots of wind mixing and bubbles swept under the surface, they get under the transducer and block the pulse that you send out, and create quite a bit of interference. So really, it's going to be a weather window, and one of the things we're trying to do here is sort out, you know, what the operational limits are.
And from a passive acoustic standpoint, there will be sounds of water slapping the hull that we will hear. We're hoping that these won't be so loud that they mask the sounds from the whales themselves, but that's one of those unknown feasibility variables that we hope to test. The Saildrone will be sailing towards some of our long-term moored passive acoustic recorders, and so we will be able to do some ground truthing from what we're hearing on the Saildrone's acusons with what we're hearing on our long-term recorders, and so hopefully that'll help us ground truth those data. But the biological signals should be different sounds, frequency modulated, and look very different from the sounds of water slapping the hull.
Thanks, Jessica. Additional questions here in the room? Yes, in the back there.
Yeah, can we follow along with the status of the Saildrone or any of the data in real time, since it's got a web interface and a feed as general consumers of information?
Chris, do you want to address that, or I don't think Richard's on, but the question was, can the general public actually follow the track line and the progress of the Saildrone? Or Noah?
Yeah, so the short answer is, you know, this mission and last year's mission, we're still engineering missions, so these are very feasibility studies. So this is one of the things that we are working on, is how do we best present this data to the public. So I guess the short answer for this year is not in real time, but we do have a website that will probably be brought up on the link, and from there you can actually follow some of the data and some of the plots that are generated, but those will probably be, you know, a day or two behind. In the future, you know, I think it certainly is possible to do something like moorings, where you can kind of go to this site like the Weather Service and look at what the weather's like out at where the Saildrones are.
Thanks, Noah. Yes.
So as a follow-on to that question, does any of this instrumentation, is it transmitting the data in real time, or are you waiting for the Saildrone to return so that you can collect all of that information?
So the question is, and Noah, this is probably going to be for you again, does the Saildrone transmit the information in real time, or is it being collected and stored and will be retreated on return to Dutch Harbor?
That will depend partly on what instruments we're talking about here. On this cruise, things like the passive acoustics, listening for whales, they generate enormous sound files, which is a lot of data, and we're kind of bandwidth limited. We can only send so much data over satellite links. So for this cruise, we will not be getting the passive acoustics in real time, and the same thing goes for the active acoustics. You know, you're not going to be able to send, I mean, they generate, you know, hundreds and hundreds of gigabytes of data, you know, pretty much continuously. So we're storing those on board. Yeah. Wait 1 second, Alex. And but for things like meteorological data and some of the easier data, wind speeds, temperatures, things like that, that all comes back every 5 minutes we get that. And that is one of the big benefits of these platforms, and along with those user interfaces, is that we can actually look at the data in real time and we can say, okay, this looks really interesting, and we can go and explore these certain phenomenon as they happen.
Thank you, Noah. Alex?
Yeah, I just wanted to mention that at least we're sort of have a small implementation for the active acoustics, which we get some heartbeat data. Basically, it tells us that it's working. The instrument's happy and is working. It sends out a bunch of acknowledgement sort of signals that were part of the debug messages that we've actually piped through and are sending back. So I just can check them on my phone, you know, and make sure everything's still happy. And my kids tell me to stop checking the robots.
Any other questions? Question over here. Yep.
I have a question about the echo sounders. You mentioned that you will send out the low power acoustics. I assume that they will not have an impact on the marine mammal communications, but please comment on that. Another question is, by which mechanism you can differentiate different species? In other words, how do you know what you're seeing or what you're listening is from the Pollack, for example?
Okay, so the question has to do with what's for the active acoustics piece when it's transmitting, is there a concern about it interfering with marine mammals in the vicinity? And the second question, I think both for Alex and for Jessica, is for the active signal, how do you discriminate different species once you get the signal back? And for passive acoustics, how do you determine what species of large whale or marine mammal it might be that's vocalizing? So Alex first, and then Jessica.
Okay, so it was a little bit difficult to hear, but I think the first question was related to impacts on marine mammals. And I guess what I'll say about that is that this device is very low power. It's small, designed to work for long periods of time. So it's about an order of magnitude less power output than the types of devices that you have on fishing vessels or on our research vessels. It's also quite high frequency, so it isn't really a major concern in terms of marine mammal impacts. I can't remember what the second question was. Could you remind me, Doug?
The second one, I think, is in terms of identifying species. So is it a pollock, is it a cod, what's going on?
Well, you hit the nail right on the head. That's a really tough one. And in some ways, what species identification with acoustics is really a major problem, and it's a challenge. You get clues from doing analysis of the data, but the reason we call what we do acoustic trawl surveys is because we essentially rely on trawls to do a lot of the species identification, especially size, and we can't do that from a sail drone. The sort of thing that we have going for us there is that in the Bering Sea, the midwater fish community is really dominated by one species, walleye pollock, once you get out on the outer shelf deeper than about 70 or 80 meters depth. So in this particular area, when you see backscatter, you pretty much know it's from walleye pollock. And we know that from doing 40 plus years of acoustic surveys in the area. So it's a good question, but we sort of get around it by working someplace that's simple. And that's part of the reason we're doing this in the Bering Sea.
Thanks, Alex. Jessica, can you give us a sense of species ID with passive acoustics?
Yeah, that's actually one of the problems that passive acoustics faces, is we have no idea what's swimming out there past our recorders. There also is the problem that several species make similar sounding calls, but there are several call types that are unique to species. For example, the gunshot call is unique to the North Pacific right whale. So we can use these, we can use contextual clues, what species have been in the area. We can use species-specific call types to differentiate between, say, a humpback whale and a North Pacific right whale.
Thanks very much. We have 2 questions online. Do we read those out? Yep. Okay. The first one has to do with, is there any concern about the sail drones being damaged by some of the large marine mammals? And would they look tasty to orcas? I could answer the one on would they look tasty to orcas. I'm going to boldly say no, but Jessica, you could disagree. And then I don't know about breaching whales landing on a sail drone. That would be incredibly bad luck, and I'm an optimist. But Jessica, you may want to comment on that as well.
Yeah, well, I can't say as to whether a whale would want to breach on top of a sail drone or not, but their hearing sensitivity is very, very high, and so they will be able to hear sounds of the water hitting the hull, so they'll know that the sail drone is coming. So that combined with the fact that the drone is cruising at about 2 knots average gives the whale plenty of time to move out of the way. So a collision between a sail drone and a whale is very unlikely.
And then we have another question. Will the drones stop in a coastal community, and is there any collaboration with subsistence users? That's a good question. At this point, we do not envision the sail drone motoring up to a community and somehow signifying its presence and then leaving. At this point, it's going to stay out at sea, and we'll pick it back up in Dutch Harbor in September. But that's certainly something we could consider in the future. We would want to make sure our communication protocols are in place. Is there another question? Can school students track these drones on a regular basis on the web, and can we keep tabs on what the drone sees? And Alex, you may be able to help with this one, and Noah's addressed it a little bit. We won't be having real-time tracking of the sail drone, but we do have a website that will show where the drone is in relatively current time. And I think, as Noah said and Alex said, there is some information that's being downloaded in real time to the principal investigators, and some of that may be made available on the web as well. The temperatures, salinity, wind speed. It actually has 4 little cameras on it, and I don't know if those pictures can be downloaded. Noah's saying they can. So we can actually get something of what the sail drone is seeing, like a breaching humpback or something. Hopefully it's cameras on all the time, so we wouldn't miss that if it happened. Hopefully we'll be able to see some interesting pictures from these small cameras. But Alex, is there anything else that you want to add in terms of information that'll be transmitted?
No, I think you have it pretty well covered. I'm not sure exactly what's going to go on the website, but maybe Noah can speak to that. Or Heather.
Okay, thank you.
Doug, can I also jump in?
Sure, absolutely.
We're going to have a web blog on the Alaska Fisheries Science Center webpage that'll show some of the recent sail drone tracks along with the northern fur seal tracks. So if people are interested, they can take a look at, see where the fur seals are, not in real time, but in recent time, in relation to where the sail drones are, and see how the two are working together to collect data.
That's great, Carrie. Thank you. Okay, any other questions on the online? That sounds good. Any other questions in the room? Is Chris still here? Well, we want to thank everybody for both coming here in the room as well as those of you who participated in the YouTube chat. This is a first for us. I hope you found it interesting. I want to thank all the scientists for being available and kind of answering questions in real time and without knowing what the questions are. That's always a challenge. I hope you found it interesting. This is a technology that we intend to work closely with our partners, NOAA, as well as the industry and academia. And it's just a real exciting time. So when we pick the drone up in September, hopefully we'll have all the information that we expect and no big surprises or no unpleasant surprises. And we'll do this again. So thank you all very much for coming. And thank you again, those on YouTube chat. Have a good day.